record of it. All right, so 6.4.3. We're going to be talking about the first fundamental theorem of calculus. We kind of did things out of order because, well, it made sense for us this year, and we didn't talk about the first fundamental theorem yet. We're going to do that in a minute. But honestly, out of the two theorems, the second fundamental theorem of calculus, which is what we learned last week on Thursday and Friday, that's the more important of the two. So before we can even start talking about the first, I gotta check your understanding of the second. If I gave you some function like, I don't know, the integral from 2 to 5 of 2x dx. If I asked you to do that right now, how easy to hard would that feel for you? I'm going to send out a poll. How easy to hard is that? All right, with that, mostly people are saying it's easy. So with that, it's probably not a great use of our time to make you do it now on your own. Instead, let's have somebody be brave enough to unmute yourself and tell me how you would do this. So if this isn't a problem I gave you, how would you do it?
First, find the antiderivative.
First, find the antiderivative. Antiderivative of 2x will be x squared. And then what do I do with that? It's a long dead space. Go ahead. What was that?
Draw the line thing and then write a 5 and a 2. And then
what does that line thing mean?
You have to plug in the number for x.
So yeah, I'm going to
plug in 5 and then plug in 2.
I plug in the 5, I plug in the 2, and I subtract those two things. 5 squared is 25, 2 squared is 4. The answer is 21. You guys mostly said this was easy, which is excellent, so we're not going to spend a lot of time with that. But I want to check Friday's stuff, because there is a difference between these two questions. I'm going to say, let's say we've got question number 1 is the integral from 0 to 5 of x squared minus 4 dx. In question 2, here is the graph of x squared minus 4. And question 2 says find the total area. Between y equals x squared minus 4 and the x-axis. In other words, it's asking for you to find, I gotta finish the question. From x equals 0 to x equals 5. In other words, that one's asking you to find that total area. What's the difference between those two questions? Actually, you know what, stop. I'm going to poll you guys. Will these questions yield the same answer? So will the answer be the same, just yes or no? I've got 9 out of 21 responding. Yes or no? Will these two questions give you the same number for an answer? All right. I've got half of you responding, so I'm worried about that a little bit because the other half, I don't know what's going on. So are you seeing my polls? Out of those that didn't answer. Like, this wasn't one you had to work out to answer. Like, I'm curious why we didn't get an answer. All right, this is being very hard to teach you today. I'm just going to ask an "Are you there?" questions, or even "Can you see this poll?" So yes, I can see this poll. Then you click yes. No, I can't see this poll. You're not going to click no because you can't see it. Somebody click no. All right. 17, 18, 19. All right, so 20, 21 of you guys, 20 out of 21 of you guys can see this poll, and you're getting it. So yes, you can see this poll. Excellent. The question I asked before, I'm not sure what was hard about it. So if you just don't know, write kind of. Kind of can be the don't know. If I gave you these two questions and I asked you to answer both of them, would your answer be the same for both of those? Yes, the answer is going to be the same, or no, it's not. Yes, it's going to be the same. No, it's not, or kind of, I just don't know. All right, so there's definitely enough answers here that you're all across the board. About half of you say yes, and about half of you say no, or you don't know. We should talk about this. So before I talk about the one on the right, the one on the left, would it be helpful to work out this one by hand just to make sure we can? So this one right here. Would it be helpful to work out that one by hand? So yes, I think it would be helpful to work that out by hand just for review, or no, it wouldn't be helpful. I can definitely do that. I don't need any more teaching on that. All right, there's enough of a bounce, but there's enough yeses that will definitely do it. There's enough no's that it's probably not worth our time to have you do it on your own. So I'm going to do it. I've got to shut my program off quick because my iPad suddenly got slow, which it'll occasionally do, but if I restart Notability, it'll speed back up. All right, so here are our two questions. I am going to focus on just this one by hand. Let's figure this one out by hand. All right. So, what is the first step?
Find the antiderivative.
Find the antiderivative. Antiderivative of x squared would be an x cubed, one higher power. But I'm going to need a 1/3 out in front of that, so when the 3 comes down, I don't have a 3 here anymore, right? Because the derivative should be that. So the antiderivative would be 1/3 x cubed minus 4x, because the antiderivative of -4 is 4x. So there's my antiderivative. With this thing, I'm going to plug in a 0 and plug in a 5 and find my answer. Plugging in a 5 would be 1/3 5 cubed. 5 cubed is 125, so that'd be 125 thirds. Minusing plugging a 5 to the 4, that'd be 4 times 5 is 20. And all of that minus plugging in a 0 for both of those would be easy. That'd just be 0 minus 0, right? That's just going to be 0. So my final answer is 125 thirds minus 20, which is the same as 125 thirds minus 60 thirds. So I can actually combine them, 65 thirds. That is the integral from 0 to 5 of x squared minus 4. Now, the other one. The answer to this is not going to be the same. It's not going to be 65 thirds. It's going to be less than 65 thirds. In fact, it could be a negative number. My guess is it would probably be a negative answer. Somebody talk to me about why, I'm totally wrong. It's not going to be a negative answer. It's going to be more than 65 thirds. It's going to be more than 65 thirds. So somebody talk to me why the answer is not going to be the same for problem 2.
Because that that area under the x-axis is going to be positive as well.
Yeah, so when we take an integral, this area is given a negative value. And then the area on the right, above the axis, that's given a positive value. So I'm taking a negative value and a positive value to get this answer. When I ask about finding area, finding total area, have that word kind of be drilled into your head. Anytime it says something about area, we want to count all areas as positive values. We're not like, that's a negative 12 square foot bedroom. Like, that's ridiculous, right? Well, a 12 square foot bedroom is ridiculous. But regardless, area is always positive. So for this one, I'm going to share my screen. I'm going to share a different screen. I'm going to bring up Desmos. I'm just going to do it on my calculator to save a little bit of time here because we still haven't talked about today's stuff, which is going to be important. But seeing as where we were on Friday, probably worth talking about this. So if I do x squared minus 4, there's that graph. I'm going to show a couple of things. First off, the integral from 0 to 5 of x squared minus 4 dx. All right, come on. There you go. 21.666, which is the same as 65 thirds. We got that answer correct before. However, if I want the total area, I need to find this area down here and that area up there separately. It crosses right at x equals 2. So if I wanted to find those, I could say, hey, let's find the integral from 0 to 2, which is negative 5.33. And then I could find the integral from 2 to 5, which is 27. And then this negative 5.333 integral, well, that's still a positive area. So my total area would be the 27 from over here, plus a positive 5.333. My total answer is 32.333 for the total area, versus the integral by itself was 21.66 because it counted this as a negative value instead of a positive. So when it asks for total area, the easiest way is to split it up into 2 sections, 1, 2, and then count that value as a positive value because area can't be negative. So I say the area on the right is 27, the area on the left is a positive 5.333 because we can't have negative area. So the total area is 32.333. Did that help? So let's ask easy to hard. How easy to hard does the difference between asking an integral and asking for total area feel to you? Like, yes, I can definitely tell the difference between asking for the total area versus asking for an integral, or no, it's what you're talking about doesn't make sense. Excellent. Looks like we got 1s, 2s, and 3s. If it is harder for you, stay after class. We can talk to you about it. It's actually it's not too bad. Just one last thing. If you wanted, there is a shortcut for this when you're allowed a calculator. If I was trying to find the total area from 0 to 5, we know area has to be positive, so I wouldn't want this to be counted as negative. Check this out. If you do the absolute value, how is the absolute value of x squared minus 4 different than just y equals x squared minus 4? Same stuff, but anything below the x-axis was flipped up above the x-axis. All right? So if I found the integral from 0 to 5 of the absolute value of x squared minus 4, take a look at that. 32.333 because when I change it to an absolute value, it takes this area, which used to be down here, and flips it above the x-axis. So it counts that as positive, counts that as that area as positive, and my total area, 32.33. So if you have access to a calculator, a shortcut for finding total area is just do the integral of the absolute value of your equation, because then none of that equation will be below the x-axis. It'll all be above the x-axis. All right, we can start today's stuff now. That was a big, long review intro, but it was important stuff. I feel it was well worth our time, but it's probably, hold on. But I should probably just check with you guys to see if that review was helpful to you. So we have a review coming up Thursday. Somebody left class, that's sad. We have a review coming up Thursday, but was that review helpful? So yes, that was helpful to me. Kind of, it's not bad to do it. No, it was just bad. All right, the large majority of people saying yes, it was helpful. Good, I'm glad to do it. I tend to go off on tangents. It takes a little bit of time, but it tends to help people's understanding a little bit better. There was if ever it isn't worth your time, it's good to know, but it seemed to be. All right. So today we're going to do a weird one. We're going to do things like this. We're going to find the derivative of an integral. Let's see, I want to just look at this. Yeah, that's fine. Okay. So often, this problem will be written like this. I'm just going to write it off to the side so we can see it. It'll be written as d dx of the integral from pi to x of sine of t dt. So often you'll see this problem here and that problem there. It's two ways of writing the same exact problem, right? On the left, I said, find this integral, we'll call it y, and then find the derivative of y. Here, I'm saying, here's that integral, find that integral, and then take the derivative of it. They mean the same thing, right? We're taking the derivative of an integral. And the integral is weird because it's going from pi to x. But I just want to check that we understand the question and we understand these two things make sense. So I'm going to do two quick yes/no questions. First off, does it make sense that the left-hand side and the right-hand side mean the same thing? Like you can look at that and understand, yeah, they're just same question written in a different way. All right, lots of yeses, a couple of kind ofs. This speaks to your understanding of notation, just understanding that this is two notations that mean the same thing. That's fine, that's good. I don't remember the other question I was going to ask. All right, let's just do this then. Okay, let's do, you know what, because I think your homework's going to be like this, let's actually do it like the one on the right. I'm going to change each of these. And we're going to do it like the one on the right. I'm going to just take a white marker, go over this, then I'm going to change it to black. And we're going to do it like this. The derivative of an integral. All right. Let's start with this part. And we'll just ignore the derivative part and take care of that later. So we're going to find the derivative of whatever this part is here. How do we do this integral? All right, how do we do any integral?
Find that antiderivative.
Yeah, find the antiderivative. What's the antiderivative of sine?
Negative cosine.
Negative cosine. And so we're going to do a negative cosine, and then we're going to plug the top one in, and we're going to plug the bottom one in, and we're going to subtract. So I'm going to have the negative cosine of plugging the top one in is an x minus a negative cosine, plug the bottom one in, pi. Does that step make sense to you? So yes, that totally makes sense. You just find the antiderivative and plug the stuff in. No, something was weird about that. Excellent. People largely saying yes. I'm going to end the poll there. So yeah, it's not any different even if you have a variable right there. It's still the same process, right? We can go a little bit further here. We can say, all right, this is going to be the derivative of negative cosine of x minus a negative is plus. Let's see, cosine of pi is -1. So plus -1. I could have just wrote -1, I guess. And now we just take the derivative and we get our answer. What is the derivative of negative cosine?
Sine.
So that'd be sine of x. What is the derivative of a constant?
0.
0. So sine of x plus 0, which is just sine of x. All right. Now, the important thing here is take a look at what I started with and what I ended up with. What do you notice?
It's almost the same thing, just with a different variable.
Yeah, it's almost the exact same thing. The only difference is the variable changed to an x. We had kind of talked about dummy variables before. Dummy variables are often like just a t or whatever else, where the variable doesn't matter because it goes away in the end. All that really happened is I found the integral and I plugged an x in, and then I found the derivative. But since integration and derivation, since integrals and derivatives are opposites, I pretty much ended up exactly where I started. The only difference is the variable changed to an x. This fact that the derivative of an integral is straight back to the original function is actually what led to the second fundamental theorem of calculus. And so this is the first fundamental theorem of calculus. And it actually is fairly easy. All it basically says is if you have an integral that goes from some constant to an x, and then you want to take the derivative of that integral, you're going to end up right back where you started because a derivative and an integration are opposite operations. Just like multiplication and division are opposites, or adding and subtracting are opposites. Taking the derivative and taking the integral, they're opposites. So they'll undo each other, so to speak, right? Just like if I started with 5 and I add 3, and then I did the opposite of that and I minus 3, I end up right back at 5. Well, if you've got some equation, 3x squared, and you take the integral, and then you do the opposite of taking the integral, you take the derivative, you're going to end up right back where you started. The only thing that's going to change for this particular function is because I'm plugging an x in place of the t, I'll have the same exact thing out, but instead of a 3t squared, what will my answer for the derivative be?
3x squared.
3x squared. That's all there is to it. That's a fairly major concept. It can seem weird at first, and I'm okay with that. I'm going to ask easy to hard. So 1 being, this is easy, I got this. 3 being, it's weird, but I think I get it. And 5 being, yeah, there's something about this I am not understanding. Like, where are you feeling with this first fundamental theorem? Excellent. Lots of 1s, 2s, and 3s. Couple of 4s. It's all right. It's not bad at all. The first fundamental theorem of calculus, this is in your book. It's in your notes. You can read it. Again, it's the same thing I said. All it says is that if you've got an integral from a to x, where a is a constant, right? It's on that interval a to b. Then the derivative from a to x of f of t dt is just f of x. It's saying that thing and that thing, it's going to be the same exact function out. You're just going to have an x in place of the t. So when you take the derivative of an integral, and the integral is going from some constant to x, you're going to end up at the same place you started out at. Let's just double check this. This problem. I could use the second fundamental theorem. I could say, hey, let's find this integral, and then we'll take the derivative of that integral. But at this point, we should be able to be like, nope, I got this. What I want you guys to do is, yeah, in the chat box, tell me what you think the derivative dy dx of this integral is going to be. So y is the integral. What is the derivative of that integral? Go ahead, tap it in the chat box. Direct message me if you can so it doesn't fill out everybody else's chat. But if you can't, go ahead and just send it to everybody. I want to see if you guys got this. So tap out what you think the answer to this is going to be. And if you don't know how to do exponents when you type, it's just the Shift 8. It's that button. Yep. I'm going to wait for a few more people to put in the answers, but everybody who's put in an answer so far got it exactly right. Excellent. All right, perfect. I'm going to move on. Everybody's that I'm seeing is getting it. The thing about this, I could have tried finding the integral, but I don't know what the antiderivative of this thing is. So I don't know if we could have done it. Actually, I do know we can find that, but it's a lot harder. However, since I'm just taking the derivative anyway, it's going to be the same exact function, but with an x instead of the h. So it's going to be an x e to the x plus 5x cubed. That is all there is to it. We're going to start shaking things up and making it just a little bit weird. So before we do that, I just got to check easy to hard one more time. 1, that problem was easy. I definitely get this now. 3, it's okay. 5, that's hard to do. All right, excellent. So basically the big thing to understand is that taking a derivative and taking integrals are inverse operations. They undo each other. You end up right back where you started. Good, okay. Let's start shifting up a little bit different. What if I do a problem like this? So here is my y. I'm going to find this integral, and then I'm going to take the derivative of that integral. But it looks a little bit different now. What is different about it?
The fraction.
There's a fraction, yep. But more importantly,
It starts at x.
yeah, so our first fundamental theorem was kind of specific. It said my first fundamental theorem had an x on the top and just a constant on the bottom. They used a for a constant because it could be any constant. But just a constant like a 5 or 6 or 97, whatever, some constant on the bottom, and your variable x on the top. Right? Like that was what our first fundamental theorem said. It said when it's set up like that, your derivative and your integral undo each other, and you end up right back where you started. All of a sudden, I have the x on the bottom. My first fundamental theorem is not equipped to deal with that. I need the x on the top. Is there a way I can move the x to the top? In other words, is there a way I could write this same exact integral, but write it with the x on the top and the 5 on the bottom?
Can't you just make it negative and then flip the integral like that?
That's it exactly. A few days ago, we learned about properties of integrals, and one of the properties of integrals we learned was that if we switch the upper and lower limits of integration, if we switch that 5 and the x, I can get the exact same thing if I say make it the negative. Like these are equal. When you switch it, you get the same answer, but a negative version of that answer. So as long as I put that negative sign out front, this thing and this thing will yield the same result, right? So I can rewrite it like this. And now I can find my answer, right? I say, hey, I know this part of it. That part of it there is just going to be the same thing, but with an x in place of the t. And so then my answer is going to be the same thing, but with a negative in front of it. My answer is going to be a negative 1 over x squared plus 3. Or if you prefer, negative 1 over x squared plus 3. Right? So when you have problems and it's not set up nicely where you have that variable on top, then we got to use our knowledge of integrals, and we got to think, well, how can I flip them or move things around so that I get something I want and I can just get that answer out. All right, does that flip make sense? So 1 to 5, again, I'm asking a lot of them, but it's really a good one to check in. So yeah, I get it. You just flip it and make the answer negative. Or no, that's hard. All right, excellent. Are you ready to move on? I'm not sure how many of you guys are actively taking notes, and I feel like I'm going fast. So yes, let's move on, or no, I'm writing something down. Can you give me a minute? All right, you guys all said you're ready to move on? Let's move on. Oh, 1 no. Okay, I'll wait just a little bit for that 1 no to give them time to write stuff down. While I wait, is there any questions people have about this or anything else in calculus? All right, second question, just because I'm curious. Does anybody prefer, I'm going to call that A, I'm going to call that B. Just because I'm curious. Whoever is still writing stuff down, don't answer the polls, you write stuff down. How many people prefer the fraction written in the form that I've got with A, and how many people prefer it in B, and then how many people just don't care? So let's do, I'm just gonna do an A-B poll. Yeah, I just have an A-B. So if you prefer A, type A in the poll. If you prefer B, type B in the poll. Oh, wow. All right, that surprises me. Most of you guys prefer writing it in the top version, A. I always prefer taking my negatives and putting them in with the numerator. Negative times 1 is negative 1. But all right, if you guys prefer writing your negative on the outside, I'll try to match you guys. That is new. Most people, and I've taught in the past, prefer it in the numerator. But you guys prefer it on the outside? Okay, I'm just going to check. Which do you like better? A negative 1/2 like that, or negative 1/2 like that? I'm curious if it's the same when it's a number as when it's an expression. So an AB again. How many people prefer the negative 1/2 in A's form? How many people prefer the negative 1/2 in B's form? All right, you do guys, okay. All right, negative on the outside. I'll try to remember that. I'll try to match your preference. If you like the negative on the outside, excellent, I can do that. I've always preferred it there, and historically, that's where other students have preferred it. But something about distance learning or something about your guys' year, maybe the task teachers you've had, I don't know. That's interesting. Cool. I learn something new every day. You guys prefer your negatives on the outside. All right, let's try this. Oh, chain rule. We might have to apply the chain rule. So you might remember the chain rule with derivatives. It has to do with a problem like this. What makes this problem weird or hard compared to the other ones we've been doing? Somebody's gonna have to unmute yourself. Come on, people, you can do it.
It's x squared.
It's x squared, right? Again, our first fundamental theorem is kind of limited. If I come back up to here, our first fundamental theorem said, hey, it works as long as you go to an x. But then all of a sudden, now I'm going to x squared. And like, I don't know how to deal with that. So one thing, if you ever do get stuck and you're like, I don't know how to deal with that, you can always default back to the second fundamental theorem. You can say, all right, well, here's an integral. I want to find the derivative, dy dx, of that integral. but I don't know how to do it, so let's just find these separately. Let's actually find this integral first. So if I found the integral would be, well, first you find the antiderivative of e to the t. What's the antiderivative of e to the t? Come on, you know this one. It's your special one.
Is it just e to t?
It is e to the t. Antiderivative of e to the t is e to the t. And we're going to plug an x squared in there, and we're going to plug a 2 in there. We're going to see what we get. That'll be e to the x squared minus e to the 2. That's my integral. And now I want to find the derivative of that integral. All right, so dy dx would be the derivative, d dx, of e to the x squared minus e squared. All right, the derivative of e to the x squared. Derivative of e to the x, e to the anything is e to the anything. It's going to be e to the x squared. But chain rule says then you look on the inside and you multiply by the derivative of the inside. So it's going to be e to the x squared times 2x. And then you do the derivative of e squared. This gets people sometimes, so I'm going to write my minus. What is the derivative of e squared?
E squared.
That's what everybody says. It's actually 0. Can anybody explain why it's 0? All right. If I gave you y equals e to the x, y prime is definitely e to the x. Derivative of e to the x is e to the x. If I give you y equals e to the 2, y prime is 0. Anybody know why?
Is it because the exponent is a constant?
Yeah, because e is also a constant, right? E is 2.71. This is really 2.71 to the 2 power. This is just a number. And the derivative of a constant is always 0. So when I take my derivative, I'm going to have e to the x squared times 2x minus 0, which is just e to the x squared minus 2x, or times 2x. There is my final answer for this problem. Now what I'm going to do is I'm going to actually erase all of my work, and we're going to look at where I started at and where I ended at. Because that's actually the important part. I started here, I ended there. Is there a way you can see a shortcut to get to that point without doing all of that work of actually finding the integral and then taking the derivative of that integral?
It looks like you just plug in the x for where it needs to be plugged in, and then you multiply that by the derivative of x.
Exactly right. You just take the e to the x and you plug it in there and then multiply by the derivative. So the chain rule works with this as well. You could have, now I gotta stress this. If you want, you can always go to the work of finding the integral and then finding the derivative of that integral, and you'll get the right answer. But if you are quick enough to notice this, there is a much shorter way. So let's do it the shorter way. Here I've got another integral, and I'm going to ask for the derivative of that integral. This time it's to the x cubed, not a problem. We can find the derivative of that integral. It's going to be the same exact function, but instead of cosine of t, it's going to be cosine of what?
X to the
X
third.
cubed.
Yeah. And then because of chain rule, it's going to be multiplied by what?
3x squared.
3x squared. That's all there is to it. So if there's anything other than an x here, not a problem. Still plug it in, just like always. But then because when we take the derivative, the chain rule is going to happen, and we're going to multiply by the derivative of the inside. You just multiply, put that by that derivative, and you got your answer there. 1 to 5, how easy to hard do these problems with the chain rule feel to you? Excellent. Lots of 1s, 2s, and 3s. People feeling they got it. Definitely use that shortcut. It makes it so much faster and easier. If ever you feel stuck and you're just not sure, you can do it the long way. It totally works. All right. I think let's just do one last problem and then we are set. This one makes things a little bit harder. What makes this one harder?
There are 2 x's.
There are 2 variables, and that's a problem. So what I'm going to do is I'm actually going to split this up. I'm going to say, hey, this integral, I could say that's the same as the integral from x to some number. Pick a number.
22.
22. From x to 22 of sine of t dt plus the integral from 22 to x squared of sine of t dt. I'm taking a single integral and I'm splitting it up. And the reason this works is if I've got sine of x, so sine of x looks like this. If I put, I'm just going to say 22 is here. I have no idea. 22 is there. Let's say x is right here, and x squared is right there, right? If I want the integral from x to x squared, that would be the same as taking the integral from x to 22, and then adding the integral from 22 to x squared. So I can split them both up. So that split is important. So before I move on, does it make sense that I can split the integral up like that? Just some random constant thrown in there. So yes, it makes sense that you can split that up, or no, I don't understand how you did that. All right, most people saying yes, but let's, there's some no's, so let's see if I can make this make a little bit more sense. I'm going to take that 22 out there. All right. Sine of x looks like this. Now x and x squared could be anywhere, but I'm going to assume they're positive, and it really doesn't matter because the math is going to hold out anywhere. But if I said x is right here, then x squared would be that number squared, probably going to be out here somewhere. And the integral would find the integral from x to x squared would be all of that area, right? Well, there's definitely some constant between there, right? So what I'm doing is I'm saying, hey, there's some constant there. Let's call it c. And I could find the integral from x to c, and then from c to x squared, and that'll be the same thing as finding the integral from x to x squared. Explaining it that way, does that make sense? So yes, I totally get it. You can split it up. Let's move on already, or no, I don't. All right, good. People saying yes now. Now, I had you guys choose a 22 because a lot of times it's easier for students when there's an actual number there. And since there's definitely going to be some constant in there, and the fact that the constant, what the constant is, doesn't matter, I just said, let's call it something. Let's say there happens to be a 22 in there. So we said that c is 22. Is it really? I don't know. It doesn't really matter. If I wanted to be purely mathematically correct, I would be better off to say it's just some constant, some c. But for the sake of our math, let's just say that constant is 22, because then these problems become a lot easier to find. This one right here. If I wanted the derivative of that integral, the derivative of that integral is really, well, isn't too bad. How would I find the derivative of that integral? What don't I like about the way it looks right now?
It's just the derivative, and you replace the t with an x and make it negative.
Yes, perfect. Why am I going to have to make it negative?
Because the x isn't on the top.
Because x isn't on the top. Exactly right. So if I wanted to show my steps, I could say, hey, I don't like the x on the bottom, so let's make this a negative, and then put it from 22 to x, sine of t dt, plus the integral from 22 to x squared of sine of t dt. And then when I take the derivative, so let's do the derivative. Now this is not a problem. The derivative of that one, well, we know this part. We just plug in the x because a derivative of an integral, I end up right back where I started. It's going to be a negative sine of x plus the derivative of this one. Well, that's going to be a sine of x squared times what?
2x.
Times 2x because of the chain rule. There is my derivative of the integral. All right, how did that feel? So 1 to 5, yeah, I get it. You just split it up into two different things, and then you found those ones separately. Or actually, that was really hard. Excellent. All right, I'm going to end that poll. Just for the sake of notes, I'm going to put these notes up there. I'm going to rewrite this into the other form because it tends to be easier for people to see it in that form. When I say that, I'm going to write it like this. I'm going to say, hey, we are going to find the derivative of this integral. And then it'll be the derivative of all of that, which would be equal to the derivative of all of that, which would just be a negative sine of x plus sine of x squared times 2x. Same math, it's just instead of having it as finding the integral and then derivative, I just put the derivative thing on the outside. Because I'm going to upload these notes, and I think those are a little easier to read when it's written in that form. All right, I think you guys got it. I'm going to skip, well, I don't know. I'm just going to ask you guys, would it be helpful to try one more together just to make sure we have this down? Same type of thing. Would it be helpful to try this? Or yes, yes, let's try it, or no, I don't need to. I think I got it. All right, I'm going to end that poll. Let me see what I got here. Let's do this. So this one, just one more to try. We're split about 50-50 with yeses and nos. If you're yes, you'd like to try this just to make sure you have it down, stick around, let's do it. If you're no, class is done. There's an assignment, give it a shot. Just remember, taking the derivative of an integral, they're opposite functions. See some of you later. The rest of you guys, we'll do this. All right, again, just for ease of use, I'm going to rewrite this as this. The derivative of that integral. All right, what would you do first? All right, I should just ask a different question. Do you guys want to try it on your own or together? So yes, I want to try it on my own. No, I think we should do it together. All right, most people saying no, you want to do it together. Okay, then you're going to have to unmute yourself and talk. What makes this one feel hard? You can do it, people. What's making this one harder? I'll give you a hint. It's not just like a derivative of 8 to the x.
The 3 to the x and e to the x.
The 3x and the e to the x. That's what makes it hard. So we're going to have to split this into two separate integrals. So you're going to help me out. So this is going to be the derivative of the integral from 3x to some number. We could call it c, or we could actually put a number here. What do you guys want to put there?
9.
9. So let's say from 3x to 9. It doesn't really matter. It just has to be some constant of 5t squared dt plus the integral from what to what?
9 to 3x.
9 to e to the x of 5t squared dt. So the first step is to split that integral up so that I can actually have a constant there. This integral is annoying. What's annoying about that integral?
The x is on
3 to
the
the x.
bottom.
The x is on the bottom, right? So we don't want that. So we're going to rewrite this as d dx. We're going to make it a negative integral from 9 to 3x of 5t squared dt plus the integral from 9 to e to the x of 5t squared dt. Now it's not a problem. How do we find the derivative of this integral? Well, since taking the derivative and taking integrals are opposites, there's a negative sign, so it's still got the negative sign. But instead of 5t squared, I'm going to write 5 times what squared?
3x squared.
Yep. But since there was something other than just an x, since it was a 3x, I got to multiply by the derivative because of the chain rule. I got to multiply, in this case, by
3.
3. Plus, do it again. The derivative of this stuff. Well, derivatives and integrals are opposite functions, so I'm going to get the same exact function out, but instead of 5t squared, it's going to be 5 times what squared?
E to the x.
E to the x squared. And then because, again, this is something other than just an x, chain rule says I have to times by the derivative of the inside, so I have to multiply by e to the x. There is my answer. You can be done at that point and say, there, I found it. If you wanted to simplify it, you absolutely could. Simplifying this, that's 5 times 3 is 15. Square that is 9. 9 times 15 would be 135. So negative 135 x squared. I believe I'm right on that. I can check it. Plus that'd be 5. Well, this would be 5 e to the 2x times e to the x, because that's one of my rules of exponents. And then when I've got two things multiplied by each other, you can add the exponents. 2x plus another x is 3x. So I can rewrite this as 5 e to the 3x if you wanted to simplify it. All right, that's it. I'm going to stop the recording, and then any questions people have, we can ask them.